Dictionaries are one of the most important data structures in Python interviews. In this video, we will solve 13 practical dictionary challenges with clear inputs, outputs, and explanations. If you want to get faster at real Python problem solving, this is a great place to practice. We start with the dictionary patterns that appear constantly in interviews, counting data and finding the strongest value. Counting frequency is one of the most common dictionary tasks in Python. We create an empty dictionary, loop through the words, and update each count with get so missing words start from 0. Now we run the script and look at the frequency dictionary. Let's break down why this works. The first time Python sees a word, get returns 0, so the count becomes 1. Every later time, get returns the existing count, and we increment it again. Now let's show the best practice to remember. For simple interview code, get is clear and easy to explain. In production, when counting is the entire job, collections. Counter is often even shorter and more expressive. For practice, change the input to a list of colors and build the same kind of frequency dictionary. Then add one more repeated color and predict the output before running it. Once you have a frequency dictionary, the next interview question is usually finding the winner. We use max on the keys, but we tell it to compare by each key's value in the dictionary. Now we run it and check the selected item and count. Let's break down the result. Max looks at apple, banana, and orange, but counts. Get makes the comparison, use 4, 9, and 2. Since 9 is the largest value, the answer is banana. Now let's show the best practice for real code. Max with key equals dictionary.get is clean, but an empty dictionary would raise an error. When input can be empty, check that case before calling max. For practice, add grape with a count of 12 to the original dictionary. Before running the code, decide which key should print and why. Next, we combine dictionaries without losing information when the same key appears in more than one source. Merging inventories is a realistic dictionary problem because the same product can appear in multiple reports. We start with a copy of the first warehouse, then add counts from the second one item by item. Now we run it and confirm that mouse is summed instead of replaced. Let's break down the merge. Laptop is already in the copied dictionary and never changes. Mouse exists in both places, so get returns 10 and we add 5. Keyboard is new, so get returns 0 and the final value becomes 7. Let's show the best practice and a common trap. The dictionary union operator is great for overwriting, but it is not correct when numbers must be accumulated. For inventory, sales, or totals, use an explicit accumulation step. For practice, add warehouse C with more laptops and monitors, merge it into the result, and make sure repeated items increase instead of being overwritten. Now we transform dictionaries by changing the direction of lookup from names to IDs and back. Verse lookups are common when data moves between usernames and internal IDs. Here the IDs are unique, so we can safely swap keys and values with a dictionary comprehension. Now we run it and inspect the reversed mapping. Let's break down the comprehension. Users.items gives us each username and user ID together. The new dictionary puts the ID first, so we can look up the username from the numeric identifier. Now let's show the best practice warning. Direct inversion is only safe when values are unique. If two users had the same ID, one name would overwrite the other in the reversed dictionary. Practice: add Dave with a new ID and invert the dictionary again. Then try a repeated ID and notice why direct inversion can lose data. Finally, in this batch, we group records, so one dictionary key can point to a list of matching items. Grouping records is a practical dictionary pattern for reports and dashboards. We use default dict with lists so each status automatically gets a list before we append orders into it. Now we run the script and look at how the orders are grouped. Let's break down the result. The first paid order creates the paid list, and the second paid order goes into that same list. Pending and failed each get their own list because they have different status values. Now let's show the best practice for grouping many records. Default dict list keeps the loop focused on the real operation. Append this record to its group. It avoids writing the same if key not in dictionary check over and over. Practice, group the orders by size instead of status. Use large when the total is at least 50, and small for everything below 50. This variation checks whether you can create a grouping key from logic, not just from an existing field. In this section, we turn lists of records into dictionaries that are easier and faster to search. In real projects, lists of records often come from APIs or databases, but list lookup by ID is slow if we do it repeatedly. Here we create a dictionary where each key is the user ID and each value is the full user record. Now we run the script and check that user 2 can be found with one direct lookup. Let's break down why this works. The comprehension loops through every user and stores the record under user ID. So instead of checking every item in the list, Python jumps straight to the matching dictionary key. Now let's show the best habit for this pattern. Build an ID index when you know you will look up records more than once. It makes the intent clearer and avoids repeated list scanning inside other loops. Practice. Add one more user with ID 3 and name Carol. Then retrieve Carol from the dictionary using the key 3 without looping through the original list. Now we use dictionaries to validate data and find values that appear more than once. Imported data often looks valid at first, but the same value can be attached to multiple keys. Here we reverse the dictionary so each email points to a list of user IDs. Then we run it and print only the emails that appear more than once. Let's break down the algorithm. The original dictionary answers this question: what email belongs to this user? The reversed dictionary answers the interview question better: which users share the same email? Now let's show the safer way to think about validation. Dictionary keys are unique, but dictionary values are not automatically unique. If uniqueness matters, check it explicitly with grouping like this. For practice, add user U4 with the same email as U2. Your result should report two duplicated email addresses, each with the user IDs that share it. In this section, we rank dictionary entries by their values, which is a common interview and reporting task. When a dictionary stores scores, counts, or totals, we often need a ranking instead of random access. Here we sort the dictionary items by the numeric value from highest to lowest. Now we run the code and confirm that Bob comes first because Bob has the highest score. Let's break down why the output is a list of tuples. A sorted dictionary view returns ordered pairs, not a new dictionary focused on lookup. The lambda tells Python to compare the second item in each pair, which is the score. Now let's show the best version to remember for interviews. Use sorted on data.items when you need both the key and the value in ranked order. Keep reverse true for descending rankings like top scores or bestsellers. For practice, slice the sorted result and print only the top 2 users. This is the same pattern you would use for a small leaderboard or top products report. Next, we clean dictionaries by creating new dictionaries that keep only valid entries. In real inventory code, zero quantity usually means the product should not appear in an available list. Here we create a new dictionary and keep only items where the quantity is greater than 0. Now we run it and the terminal shows only products that are actually available. Let's break down the result. The comprehension loops over each product and quantity, but only writes the pair into the new dictionary when the condition is true. Mouse and monitor are skipped because their quantities are 0. Now let's show the important best practice. Prefer creating a new filtered dictionary instead of deleting keys while looping over the same dictionary. That avoids mutation problems and keeps the code easier to reason about. For practice, change the condition to keep only products with quantity at least 3. The result should still include laptop and keyboard for this dataset. Finally, we compare 2 dictionaries by using their keys, like sets and checking changed values. When configs or API payloads change, we need to know exactly what was added, removed, and modified. Here we compare dictionary key views with set operations, then compare values for keys that exist in both dictionaries. Now we run it and get a compact change report. Let's break down the three parts. Added keys exist only in the new dictionary, removed keys exist only in the old dictionary, and changed keys exist in both but have different values. That is why timeout is added, debug is removed, and port is reported with both old and new values. Now let's show the best approach for comparison problems. Use dictionary key views like sets instead of writing nested loops. The code is shorter, faster to understand, and it separates added, removed, and changed logic clearly. For practice, change the new host value from localhost to example.com. Then run the comparison again and confirm that the changed dictionary reports both host and port. Now we are moving into nested dictionaries. These problems show up a lot when you work with JSON, configuration files, and API responses. Nested API responses are great for structure, but they are awkward for flat outputs like logs or CSV rows. So let's write a small recursive function that keeps track of the current path, then we run it and look at the flattened result. Let's break down why this works. Every time the function sees a dictionary value, it goes one level deeper and extends the key path. When it reaches a normal value, it writes that full path into the flat result. Now here is the best practice to remember. Keep the separator configurable because different systems may prefer dots, underscores, or another format. Also return a new dictionary so the original nested data stays untouched. For practice, try the same function with separator set to double underscores. Then add another nested branch, like user.preferences.theme, and check that the full path is still generated correctly. Configuration often starts with defaults, then environment-specific overrides change only a few values. A shallow update would replace the whole DB dictionary, so let's write a recursive merge and run it on a small config example. Let's unpack the result. The override changes only db.port, so db.host stays in place. The debug value also stays unchanged because nothing in overrides replaced it. Now we are showing the best practice because this is where many interview answers go wrong. Do not use a plain update when the dictionaries contain nested configuration. Use recursive merging so only the intended leaf values are replaced. For your variation, add an override for debug and also add db.pool_size as a new nested setting. The merged result should update debug, add pool size, and still keep db.host. The final challenge is a small design problem. We will combine dictionary lookup with ordering to build a simple cache. Caches are useful when repeated work is expensive, like API calls or slow calculations. Here we use order dict, so each key has a value and also a position in recent use order. Then we run a capacity to example and watch the eviction. Let's reason through the important moment. After we read key A, it becomes the most recently used key, so B becomes the oldest. When C is inserted and the cache is full, B is evicted. Now we are showing the production-minded version of the idea. Ordered dict is a clear interview solution, but in real applications, you should also consider built-in tools or cache libraries that handle edge cases, expiration, and concurrency. For your practice version, change the cache capacity to 3. Insert A, B, and C, then call get on one of them, before inserting D, and predict which key should disappear. You now have 13 solid dictionary patterns you can reuse in interviews and real projects. Like the video, subscribe to Dev Level Up, and write in the comments which Python topic or challenge set you want next.